Some people are quick to anger and would throw tantrums at the slightest provocation. They are irritable and prone to outbursts. Then, there are others who are calm. They rarely overreact and would rather walk away than get into a heated argument. Yes, they get angry, but no matter what is thrown at them, their feathers rarely seem ruffled. You might wonder, what makes one person seemingly peaceful and the other riotous? Why does one person walk away from confrontations and the other always ready to go to war? The answer to this question drives the doctrines of great philosophies like Stoicism and practices like yoga. However, the answer is tied to the complexity called genes. So yes, you might be able to attain Stoicism by practice, and yoga might help you center your inner chi if you believe in it. But there are many who, without much effort, but thanks to their genes, are as peaceful. Hello viewers, welcome to my channel. In this episode, we will examine real-life case studies regarding the role of genes in behavior and other exciting subjects, such as genetic variability in behavior. Have you ever wondered about the origin of the human trait? Do you sometimes look at your partner and wonder at their idiosyncrasies? Well, scientists have proven that specific genes are linked to how we behave or react. Traits like empathy, aggression, impulsiveness, and risk-taking, introversion, extroversion, and anger are linked to specific genes in our body. For instance, one of the genes discussed in human DNA is the MAOA gene, also known as the warrior gene. People with this MAOA gene variation are known to be highly impulsive and exhibit increased aggressiveness on slight provocation. So next time you hit that CPU box for slow booting, consider whether this is not the warrior gene at work. Knowledge of the warrior gene sparks many questions, as it is exciting. Could men like Alexander the Great, Genghis Khan, and other historical figures be the result of the warrior gene? Do we have men today who truly would thrive better in dark ages, swinging axes around and plundering villages just because they feel like it? There is no outright answer to this question, as no controlled experimental studies have tested whether the warrior gene drives behavioral manifestations. The absence of controlled experiments doesn't negate the fact that the MAOA gene is indeed responsible for aggression. It only means that experiments where the gene is singled out and studied to see its link to these traits have not been done. In essence, other variables, like environment, cannot be factored out. So the evidence that exists is that the MAOA significantly predicts such behavior in a high provocation situation, but is less associated with the occurrence of aggression in a low provocation condition. Therefore, if you think you are prone to excessive aggression, you should avoid people or environments that trigger your warrior instinct. The last thing you want is to feature on the news as a gun-blazing road rager. In the same vein, we should finally accept that certain people in our lives are better not provoked. They are genetically predicted to be dangerous, very dangerous. A look at other types of genes and what they are linked to. The TPA2 gene is a gene which is related to depression. A particular variant of the TPA2 gene makes individuals more vulnerable to stress-related symptoms, such as depression. So, maybe your teenage daughter isn't mad at you. She is probably just prone to having her moods, thanks to the TPA2 genes. The DRD4 gene encodes the dopamine receptor D4, which is associated with novelty-seeking behavior like exploration, risk-taking, creativity, social interactions, learning, and adaptability. The gene is also responsible for attention deficit hyperactivity disorder, ADHD. In essence, if you can't help yourself from engaging in all sorts of outdoor activities, look inside. The culprit is the DRD4 gene. There is also the AVPR1A, which codes for the vasopressin receptor. The vasopressin receptor is involved in social communication and bonding. Variations in this gene have been linked to social behavior and pair bonding in humans and other mammals. The AVPR1A also helps modulate stress management and territorial aggression. At this point, it would seem as though the popular saying "a zebra can't change its stripes" earns its legitimacy. One could argue that people are simply products of their genes. The hot-headed policeman who is trigger-happy is simply acting out his genetic predisposition, and the housewife who is always in a mood, ready to ruin Thanksgiving, is simply acting in her element. Fortunately, this isn't entirely true. While our genetic makeup can predict our traits and behaviors, there is a second factor that can limit or worsen our behaviors: our environment. Imagine a world where we all can blame our genes wholly for our bad behaviors. There is no variation of this world that is pleasant. The worst-case scenario is people being locked up at childbirth just based on their genetic makeup. The fact that the environment can influence our genetic predisposition is a blessing for those who are genetically programmed to exhibit negative behavior. They can be helped. This is a scientific fact. Thankfully, researchers have identified 3 real-life case studies showing the impact of gene-environment interactions on behavior: the twin, adoption, and family studies. Let us go over them one after the other. The twin studies compare identical twins, who share 100% of their genes, with fraternal twins, who share around half of their genes. Researchers evaluate the similarities in their inherent general traits and the number of specific characteristics they inherited. Imagine having 2 sets of cakes. One set is made from the same recipe, representing the identical twins. The second set is made from slightly different recipes, representing the fraternal twins. When you taste both cakes, you notice that the first set identical twins taste almost the same, while the other set has little differences in flavor and texture. By analyzing these cakes, you can understand how much of their taste and texture comes from the shared ingredients, or if you like, genes, and how much from the variations, that is, genetic differences, there is between them. Adoption studies examined 2 groups of children: biological siblings raised together and adopted siblings raised together. The children in both groups share similar environmental upbringing, but only the first group shares an identical genetic background. Comparing the behaviors of these 2 groups helps researchers determine how genetics and environment affect behaviors relating to substance misuse, criminal tendencies, and mental health disorders. Family studies involve looking for similarities among family members by identifying their shared physical attributes, such as eye/hair color, facial expressions, and postures. This can help estimate the genetic components inherited as behavioral traits from parents. Some of these, for example, may include physical aggression, depression, intellectual capabilities, etc. Although these studies are essential for understanding how gene variation determines behavior, they all have strengths and weaknesses. For instance, twin studies rely on the fact that all the twins share similar cultural backgrounds to be effective. The number of adoptive families can determine the effectiveness of adoption studies, while family studies must consider complex factors such as the shared environment to draw practical conclusions. Summarily, the traits and behaviors that can be influenced by our genes include our personality features. Genes can influence traits like extroversion or neuroticism. Our cognitive performance. This includes our intelligence and learning aptitude. Our temperament. Our temperament is often influenced by genetics, which in turn can impact behavior. Aggression. Some forms of genetic mutations predispose certain people to become aggressive more rapidly than others. Impulsiveness. Genetic impact on impulsivity deals with an individual's ability to control impulses, make decisions, and exercise self-control. Sociability. Genetic factors also shape our social skills and individual preferences for socializing. To conclude, considering the similarities you share with your parents, your genes may be the major factor pulling the strings on how you respond, react, and behave in life situations. However, advancements in real-life studies have shown that while some of your behaviors manifest in your children, the social climate also plays a role in refining these inherited behaviors. It is important that while trying to gauge what they are capable of through the lens of your character, you should not overlook how variation in genes and the environment might have affected their behavior. Want personalized mental health insights through genetics? Subscribe to my channel and turn on notifications so you can stay updated on the latest genetic and psychological discoveries. In the next episode, we will be exploring real-world case studies of genetics on behavior.